All right. It looks like folks are coming in, but we'll get started with introductions. So welcome to today's Harvard Data Science Industry Seminar. I'm Jen Chow, I'm Director of External Engagement, and I am pleased to introduce today's speaker, Francesca Lazzeri. Francesca is Principal Director of Data Science and AI at Microsoft, where she leads work to build intelligent applications on the cloud across a huge array of techniques like generative AI, causal inference, computer vision, NLP, reinforcement learning. She's adjunct professor of Python for machine learning and AI at Columbia University in New York, and she's written extensively on applied machine learning and AI, including 3 textbooks. Before joining Microsoft, she was a research fellow at the Harvard Business School in Technology and Operations Management. And she's an active member of the AI community and advises companies and efforts, including close to our hearts, the Women in Data Science Initiative, and is a machine learning mentor at MIT. So some of you who have been with us for a while may recognize Francesca from previous talks she's given here at HDSI, and we're super grateful to have you back. So before I hand over to Francesca, I'd like to remind our audience that there will be time after her presentation for questions. You should use the Q&A function to send in your questions at any point during the presentation. We hope you won't be shy. So thank you and welcome, Francesca.
Thank you so much. Thank you for having me, inviting me. And, I'm very excited and also grateful today for being here because it's a way really for me to connect with the external data science community across the United States, but also across the world. So thank you, thank you. Let's get started. So as Jen said, I'm Francesca. I have been now working at Microsoft for about 10 years. I lead a few teams of machine learning scientists and data scientists at Microsoft, and we build end-to-end AI applications and also data products for Microsoft internal teams. And so today I'm here to talk more about how you can build large language models applications responsibly, safely, and also ready for production, which is something that we do every single day as a data scientist, as a machine learning scientist. So for this session, there are 2 questions that I would like to focus on and answer with all of you. The first question, as you can see, is how will large language models, LLMs, change machine learning workflows? So this is a very important topic because data scientists, I think machine learning scientists, have been great at leveraging a lot of tools and features that are part of what I call the DevOps framework. But now with the introduction and the extensive use of large language models, of course, there is also a change in the machine learning operations framework. And so we will talk more about it. And then the second question that you can see also here is how can data scientists make sure that they deploy large language models responsibly? And this is, of course, another great and important topic for our industry. Let's get started and let's see also what are the few pain points for generative AI adoption. Why I start with the pain points? Because as a data scientist, I always start with the problems. It can be a pain point, it can be a tech problem, it can be a business problem. I always start with the problem and then I immediately start looking at my data and I start to see what are the different solutions, the different machine learning AI solutions that I can build in order to answer and to solve that specific problem. And so we have been noticing a lot of different pain points from customers, from my own data scientists, machine learning scientists I work with every single day. Of course, getting started and really understanding what you can do with these new technologies is very challenging because our tech industry and also the state of art is evolving very, very quickly. The second pain point is also the development. Of course, applications often require multiple cutting-edge products and frameworks. Sometimes they are also expensive, and also the variety of options that you have as a developer, as a data scientist, is also sometimes intimidating because you don't really know where to start with the development of generative AI solutions. Context is another important point because large language models doesn't know about your data. And so you're like, okay, I understand that they have been trained and they are becoming intelligent based on many data that are publicly available. But what about my own data? What about my own context? And that has been, of course, a big challenge. Evaluation is also very interesting because we know as a data scientist, machine learning scientist, how to evaluate and validate our classical machine learning models, but when it gets to large language models, it's actually a little bit different. And today we will, of course, focus also on the evaluation aspect of generative AI solutions. And finally, operationalization. Of course, there are many concerns around privacy, security, grounding, and developers and data scientists sometimes lack the experience and the tools to evaluate and improve also the validation process of those applications. So we will see all these different challenges and how, with some of my learnings that I'm here today to share with you, you can probably follow like some general guidelines, some frameworks to be able to build your own large language models and solutions, and also just to consume them in a different way, probably with more awareness and understanding of what's going on behind the scenes. Let's start also with the operationalization side of things. So today I'm not here to tell you what are the different large language models around, what are the different models that you can consume from different open source options and the open source ecosystem in general, because I think there are plenty of resources around that can tell you more about that. Today I'm here really to talk about the practical aspects of our work as a data scientist and machine learning scientist. So let's start with the operationalization aspect of things. I noticed that right now we have been working with many customers that and many data scientists around the world that they know very well on how to build a first prototype of a chatbot, for example, or any large language model. But of course, when it gets to improve the model and make sure that the model is actually getting back to them an answer that makes sense for the context in which they're working, that is actually a very big challenge. And so they get to data scientists and they're like, okay, we want to fine tune these. We want to understand better how we can also operationalize our solution in a way that is very well integrated with our other tools that we are using every day for our work. And so this is really what I call the operationalization aspect of, honestly, any machine learning solution, any AI solution. But of course, today we will specifically look into the generative AI solutions. And so for business, of course, operationalization means streamlining essential capabilities within AI practice, including the integration of tools, as I was mentioning before, and processes necessary for the successful delivery of AI-driven business outcomes. But for data scientists and engineering teams, which are my teams, basically, it's a little bit different. This is a really personalization means how can I navigate the technical complexity while also integrating the large language models into real-world solutions. So this is really what we mean with operationalization when we think about large language models solutions. And what I have created are 4 different steps that I think are essentials when you are thinking about your operating model as a data scientist or even like as a data science machine learning organization. So these are really 4 steps or 4 aspects that are essential to set up the right operating model for your data science organization. You basically need 4 different capabilities, and as you can see, control, innovation, speed and agility, and cost. So we try, of course, always to look at cost because we, especially in my case, for my teams of data scientists, we are not in research, but we are actually applied data scientists, applied machine learning scientists. So everything that we build is something that we know for sure we need to go and to be pushed into production. And so the cost aspect is extremely important for us. But let's start with control. Control, of course, means that we need to create a set of tools and a set of applications that are secure, predictable, and flexible, and also they are ready to be pushed to production in a very quick way also, of course, with all the evaluation that is needed. Innovation, this means that we need faster business innovation through the adoption, of course, of AI services. Speed and agility, this is a business agility and reduced time to market through efficient DevOps teams. And then, as I was mentioning, also the cost. This is the efficient use of public cloud scale. And so for all these reasons, and also because of some of the challenges that I was mentioning at the beginning of my presentation that I have been noticing around, we start thinking about a machine learning operation, so MLOps framework that is also adaptable, flexible enough to include, of course, large language models. We have been sometimes calling it a large language model operation, so LLMops, as you can see from this slide. But it's really about bringing together people, processes, and platform to automate what they call the large language model infused software delivery, and also provide continuous value to our users. Of course, in this case, I personally consider machine learning operation as a concept that is able to align people, processes, and platform across the organization, from business to finance to data science team, to deliver continuous business value for machine learning applications that you are building. And from a technical standpoint, of course, machine learning operation is about bringing DevOps principle, as you probably already know, into the machine learning workflow using concepts such as we call it the CI, that means a continuous integration to the data science workflow. And also the most important step here is the automation of the training and the model testing processes using what we call the CD. That means just the continuous deployment in order to automate the test and the deployment of LLMs models, so large language models applications. And so there is this important shift, in my opinion, that we also need to realize. I would say it's a shift that data scientists and probably developers need to realize. And I like it also to present this table. I have been presenting this table also in front of a few data scientists I work with every day, because it's really more like a paradigm shift in order to optimize large language models applications. Usually, when you think about traditional MLOps frameworks, you're always thinking about either data scientists that are developing the models from scratch, the machine learning model from scratch, or sometimes they can also use frameworks and APIs of machine learning models. And then, of course, you're also talking to the machine learning engineers that most of the time they're the ones that either they help or they own the deployment of the machine learning model, and then they help with everything related to maintenance, governance of the model, so everything that we refer to as MLOps. But with LLMOps, is actually, we also talk about app developers. So those are more like a sort of, in my opinion, is more like the new version of data scientists that are able to both, of course, build models from scratch using languages like Python, but then right now they're also able to leverage models that, of course, are already offered there from the open source ecosystem. I'm referring to, of course, OpenAI, Llama, so from Meta, Hugging Face, many other open source frameworks that we have. And right now they are also doing the work of prompt engineers in order to build the end-to-end applications. And then in terms of assets to share, also this is a little bit different with large language models. We go from a model where we have a model, data, environments, features to share, to a model in which we have large language models, agents, plugins, prompts, chains, APIs. So the type of complexity is actually much bigger. And then in terms of metrics evaluations, this is, I would say, probably is the category where we have a lot of similarities, because of course also for traditional machine learning operation, you're still looking at the quality, at the harm, at the correctness, at the cost, the latency. And I would say the same is for large language models. Probably there is a little bit, actually not a little bit, there is much more emphasis and the focus right now on the arm, because of course we are looking at responsible AI in terms of biotoxicity, because of the large amount of public that these applications are consuming. And so the amount of scrutiny over there is very large, which is fantastic. But I have to say we should, of course, apply the same type of scrutiny also to any machine learning application. And then in terms of machine learning models, which is the last part here, most of the time, as I said before, in terms of machine learning models, they are built from scratch. Of course, right now we are lucky because we live in a moment of history where, of course, we have a lot of APIs, a lot of services that we can call. But at the beginning, of course, most of those frameworks and those machine learning models were built from scratch using coding languages such as Python and others. Right now, when you think about large language models, they are all pre-built, fine-tuned, and they are served as an API. So the consumption process from a data scientist perspective is actually much easier, but just that connection and consumption process, because everything else is actually much more complex. I was also already showing you a little bit of my next slide, that is the large language model lifecycle. Is actually much more complex than a normal machine learning life cycle, because there are 8 different steps that I try always to look at every time that I go and build and consume a generative AI solution. So we start, of course, with foundational large language models. This is a selection of the right foundation models, such as Azure OpenAI models, Llama 2, Falcon, and any other models also, as I was saying before, from the open source ecosystem, such as Hugging Face and so on. Then there are also a lot of data services here. Here is really the moment in which you can enrich your models with domain-specific grounding data. This is what we are also going to look later. It's called the RAG pattern, or enable in-context learning with use of case-specific example. This is the moment in which you try to really improve your application. Online evaluation is also extremely important because here is the moment in which you try to understand the performance and also the potential risk of your application. Prompt engineering, I was mentioning this right now. Of course, a lot of data scientists, machine learning scientists are learning on how to tune their application with instructions that are describing the task that we perform by the generative AI application. Experimentation and evaluation, this is the same steps as we see in many classical machine learning contexts, where of course you need to try different models and try to evaluate and validate the model that is the best for you and for your use case. The monitoring part, that is about making sure that you have a very good visibility into the performance metrics for your large language model flow, and also if you're able to detect the data drift, and you have, of course, be able to continuously communicate the model performance to your stakeholders. And then I would say the last 2 steps, even if this is a very iterative process, so it's not really a process where you completed these steps and you're done, but it's something that you need to check over time. There is, of course, what I was also referring before as a CI, that is the continuous integration, continuous evaluation, and continuous deployment of your large language models flow to maintain code quality with engineering best practices. And finally, you get into the deployment, the operationalization aspect that I was mentioning also before, because this is the moment, the step in which you package and you need to deploy the LLM flow as a scalable container for making the prediction, and also for making sure that the application that you build, the generative AI application that you build, is actually providing the right and accurate answer for you or for your customers. So there are many benefits in looking at these end-to-end large language model life cycles. In the next slides, I just try to mention some of them. There is, of course, automation. Automation, everybody in the tech industry, when we hear the word automation, we are all very happy, because of course we need automation in order to improve our processes and also in order to optimize our processes. Of course, when I mention automation, I mean always that the focus needs to be on evaluation and testing of your generative AI solution. Collaboration is another, of course, a big benefit for large language models operations, because the focus here is on sharing assets with the registries and connections, and try also to monitor the quality and the health of your application. Reproducibility here, it's really about making sure that you are building applications that can be reproduced, in the sense that they are also applications that is going to be easy for another data scientist, another AI developer to understand how these applications were built and how they can extend them or build on top of them. And here the focus is on versioning the assets used, and of course all the connection, and then finally also the deployment. Of course, if you have a strong and valid framework that you can follow in order to operationalize your generative AI solution, of course, here you can monitor the health, and also you can make sure that there are some validations that are made over time, and so you can always provide healthy and accurate answers to your final users. From a data science point of view, I also start thinking, okay, these are some of the benefits. I think it's clear at this point what's the new large language model operation framework. But from a data science and data scientist perspective, what are some of the things that you should look at when you are starting building these solutions? So I would say the first thing is, of course, the need to experiment and to try different frameworks, especially nowadays that we are lucky to live in a moment of history where we can access the open source ecosystem. So we have the opportunity to try different models. And so here I put it as the first, of course, you need to work on a platform, on a data science machine learning platform that gives you the possibility to access thousands of large language models from OpenAI, Meta is Llama 2 that I was referring before, Hugging Face, and then of course also think about how you can perform what we call now the data grounding with RAG method, and we will talk about it very soon. And then, of course, as a data scientist, you will need also to learn more about the prompt engineering and evaluation process. Another important aspect that, again, it's not new to the machine learning operation framework, but we have been looking at it very, very closely, especially with generative AI application, is the built-in safety and responsible AI. So what are some of the steps, principles, and tools that you can use to make sure that you are building responsible generative AI solutions, and then also the continuous monitoring and checking that, of course, your application is stable and is producing accurate results. And so from this overview that you as a data scientist should always look at, like if you have access to all these, I would say, capabilities and opportunities, then of course you have, in my opinion, the right platform to start building your large language model solutions. Of course, when it gets to the implementation of large language models solutions, you need also to think about additional considerations, and this is, I'm referring more to those applications that, of course, you will need to push to production. For example, you need, of course, beside making sure that you can access different foundation models, you also need to make sure that you know how to scale large language models with precision in order to ensure and streamline workflows. This is something that we were mentioning also in our previous slide, and then also making sure that you are in an environment, in a dev environment that is supporting collaboration among various type of roles. I was mentioning before data scientists, just because I work with so many data scientists and I'm myself a data scientist, but of course you need to be in an environment where there is a open communication and collaboration with machine learning engineers, app developers, and also making sure that those tools that you can use to build the trust and transparency and interpretability in your applications are shared and are integrated with the application that you're going to build. If we go back to the concept of life cycle. I'm sure that all of you are familiar with the machine learning life cycle. So we go from business understanding to data ingestions, data exploration, feature engineering, model building, deployment, and so on. So if we think about that classical machine learning life cycle, then it's probably easier to shift and think about the new large language model life cycle. For me, the large language model life cycle is still based on the same classical machine learning life cycle, but of course there are a few steps, and I try for this presentation to summarize them in 3 different steps that are probably a little bit different. And so let's look at them together. Here in these slides, you can see that I put ideating and exploring, building and augmenting is extremely important for large language models, and then there is the operationalization aspect of things. In terms of exploring, let's start with the first one. What we mean? I mentioned this probably already multiple times during this presentation today. So in this case, I mean that as a data scientist, you need to be able to explore a comprehensive foundation models catalog. So here, of course, you need to have a modern development environment that needs to bring together a large data and machine learning platform to empower data scientists and developers to look at things like, okay, what are the different open source models that I can use? Here, I just listed some of them. From Hugging Face, but also from Azure OpenAI service. Meta has been developing other great solution, NVIDIA as well. And so here, really, we can see that the platform architecture includes tools and services across the life cycle, from data ingestions to utilization, that can be realized through really this deep integration with other data science services. And in terms of the catalog that I was referring to before, here you are always need to have access to this large catalog of different models and also different languages. For example, if you want to leverage Spark for your data preparation, you should work on an environment, on a platform that is very well integrated with Databricks solutions, and also, for example, at Microsoft, we use a lot of Synapse Analytics that is very well integrated with, of course, Spark. So this can allow the data scientists to attach Apache Spark pool for data exploration and preparation. And this is, should be the same for many different tools that you are going to use. Also, another important aspect is the capability of quickly fine-tune models with your own data without managing any infrastructure, and then also making sure that you can leverage those responsible AI tools that should be integrated in your own, of course, platform. The other important aspect is, of course, the evaluation. So in this case, you have to be able to assess models. And so you can, of course, in this environment, you can quickly test out any pre-trained model using what we call right now the sample inference widget. This is able to provide you with your own sample input and test the results, which is very nice. And then on the evaluation side, you can evaluate the model with your own test data to see how the pre-trained model would perform in your own use case, which I know is another important aspect of large language models. So this is great for everything that I was mentioning also before, for experimentation, validation, and really for exploration of what are the opportunities out there for you, and most importantly, how you can connect to different frameworks when it gets to large language models. The second step in this life cycle is what I call the building, and most importantly, the augmenting aspect. So let's go into what I call the retrieval augmented generation. I mean, it's not something I called it already. It's a standard name, of course. Is RAG. So that stands for retrieval augmented generation. As you can see here, the steps and the flow, it's pretty simple. So usually we start with a user question. Then, of course, I query my data. There is then a search index, and then this can be added to the results to the prompt. Then you query the model. Then, of course, there is also a large language model that is reading these in, and then is sending the results to the end users. So this is a simple LM workflow, and it's important to understand that through this retrieval augmented generation, you are going to be able to bring your data to the prompt. So here you can combine your data with prompt, which is a very powerful concept. And this example that I put here, here we have a question answering prompt that is used with three distinct pieces, three different steps. So the prompt starts with framing and providing the generative AI with the context that it needs on how to behave. And then, as you can see, we have the user-provided question that is defined separate from the framing. And finally, there is a format source that are provided at the bottom of the prompt. And here, in this case, the generative AI summarize, synthesize all this information together and produce a correct response. So I would say that the powerful aspect of this retrieval augmented generation approach really stands in the quality of the retriever. It's very, very critical for this. We use, specifically my team, we have been using what we call the Azure Cognitive Search. And through this, we can offer the best retrieval solution through different options. We have the vector search capabilities, we have the hybrid search, the advanced filtering. Another great option is the built-in chunking, the auto vectorization, and many, many more. Here I just listed on this slide the ones that I have been using the most, but these are very powerful because through Azure Cognitive Search, you can leverage the best retrieval solution, and this is going again to give you what we call the grounding aspect, to improve the grounding aspect for your application. And so with this, what is also, I think, a very interesting aspect for data scientists is that they don't need to go directly to OpenAI, but they can use Azure Cognitive Search as a sort of an interim tool to find relevant sources from their data that you need to use for your specific application. And in this case, the benefit of the generative AI solution is that is augmented with this retrieval from, in this case, we have been using Azure Cognitive Search in order to ground the large language models with your own data. So the context challenge, or the pain point that I was mentioning also at the beginning of my presentation, somehow is solved with this additional interim tool. And then, of course, there are so many additional benefits that you can think of, because when you are going to also include this RAG approach with your prompt flow, there are many different sort of steps that you need to perform in order to make sure that you're really improving the quality and accuracy of your application. For example, data chunking here, as you can see from this slide, your source data needs to be converted to plain text and chunked into smaller pieces. Vectorization is another technique that we have been using a lot. This means that the text chunks are converted into vectors, and this is also known as embedding. Then we have the data storage. These vectors are stored and often with the metadata in order to assist in generating the different responses. The integration, of course, it's just a strong and easy connection between Azure Machine Learning that integrates with Azure OpenAI services, and then the Azure Cognitive Search capability. And then we have the customization and monitoring. In this case, you can also leverage a UI that is built in order just to leverage and test the solution that you're building. And finally, of course, the security is also something that we have been looking at very closely, because these aspect, the RAG aspect, the workflow, can be used with private networks in Azure Machine Learning, of course, in order to secure your own data. So it's your own data that you're going to use, and these are, of course, in a private network. And so this is important also when you think about the prompt engineering, because I know that, as I was mentioning also before, one different aspect of building generative AI solution is not anymore just about the machine learning model that as a data scientist you're going to build, but is also about being able to build a strong and valid and solid prompt engineering solutions. So in this case, what we do is we try to, of course, create AI workflows that connect various languages models, and also it's important to evaluate the quality of your workflow with the different data sets. Sometimes are data sets that are there for you to consume, and there are also some pre-built metrics and some of the safety systems that you can look at and you can leverage for your application. Usually when I think about the prompt engineering projects, I always try to visualize 7 different steps that I call them the prompt flow. And this prompt flow, again, based on seven different steps. And so in the next few slides, I will go through these, and I will try to also give you some suggestions, some general guidelines on how you can perform these. So the first one is, of course, capabilities overview. What do you need to think about when you are a data scientist that you want to build an end-to-end generative AI solutions? Of course, how you can manage connections. This is probably the first thing that we need to think about, because it's really about developing and managing flows that connect to a variety of foundation models, as we were mentioning before, but also vector databases, APIs, prompts, and also Python tools. Then the other aspect is about the test and evaluate. In this case, you need to test the flows with large data sets in parallel, and you have also to evaluate the AI quality of the workflows with metrics like performance, groundedness, and accuracy. Then another important aspect is being able to manage prompts. So in this case, you need to think in terms of how you can tune prompts with variants and different versions. And also you need to think about how you can, of course, compare the different prompts. And finally, of course, the deployment aspect. You need to deploy the prompt, the application that you build, in order to into a managed endpoint in order to integrate that application with the system that you are actually using for your entire project. And so this is probably the first step. And then quickly, I want to go through the other steps. The second is, of course, how you can orchestrate these flows here, how you can develop your large language model flow from scratch. The third step is about connections, so how you can manage APIs and external data sources. Fourth is about variants. This is really about creating dynamic prompts using external data and few-shot samples, and also how you can edit your complex prompt into a full screen. And this is a very helpful, especially when you have to quickly tune the prompt and also the large language model configuration with different variants. And then, as was mentioning before, there is the evaluation aspect that is about making sure that the accuracy of your models, your application is always there, and also how you can build your own custom evaluation flows. And then the responsible AI aspect, that is something that we will see also towards the end of this presentation. What are some of those metrics that you need to look at in order to make sure that you are building a solution that are not just accurate, but of course they are also what I call responsible. And so there are a few metrics that are somehow new to the machine learning field. So here I list some of them that are like groundness, relevance, coherence, fluency, similarity. So the groundness, of course, is the first one and is great at evaluating how well the model's generated answer align with the information from the input source. Relevance, that evaluates the extent to which the model's generated responses are pertinent and directly related to the given questions. Coherence, in this case, you want to evaluate how well the language model can produce output flows smoothly and also reads in a very natural way. Fluency, in this case, we evaluated the language proficiency of a generative AI application answer. And finally, similarity. This is a metric that you need to look at when you want to evaluate the similarity between a ground through a sentence or a document that you're using and the prediction sentence that is generated by your AI application. The last step in this prompt flow is about deploy, and in the next and final part of this presentation, I will talk more about the deployment and the operationalization aspect. But just to summarize and to conclude this prompt flow presentation, here is really a way to think about how you can transition in an easy way from development to production. And this is something that, of course, you need to do, especially when you are ready to push your application to production. So you think that your application is performing well and it's really the final version that you want to operationalize. While operationalization is so important, because in my opinion, it's really the moment in which you move, there is this shift from building, augmenting, but also exploring and testing different foundation models. And now you're really entering the part that is more about building the real generative AI application. And so in this final part of my presentation, I want really to talk about some of the learnings on when you have to operationalize and deploy your applications. So, of course, the value proposition of why it is important to think about manage online endpoints is that three things. First of all, it's very good for when you need to optimize cost, because of course by allowing a wide range of SKUs to choose from, then you can of course support auto scale, and also there is a much more granular cost monitoring that you can achieve with these. And then there is a streamlined development, of course, with tools that the data scientists can use, with, like, for example, Git is one of those, or local testing with Visual Studio Code, and also some tools like no-code deployment. So all these are great tools, especially if you want to streamline the development of your application. And then also improve the actual operations. This is something that we talk a little bit about during the entire presentation. Like it's important to manage the infrastructure. The infrastructure. There is, of course, making sure that there is SLA monitoring, and so this is also important to keep an eye, and don't forget about the logs and the different metrics that you need to look at to make sure that there is a continuous governance and maintenance of your application. And so in this case, of course, there are many different benefits here that you can think about. Some of these LLM ops benefits here, as you can see, it's really about deploying the machine learning workload. And here you can also think about additional benefits, such as the ability to configure alerts for violations based on organizational targets or run monitoring on a recurring basis. And then there is also a very good results in a rich dashboard that you can keep looking in terms of monitoring the health again of your generative AI solutions. The model monitoring, I would say, in any generative AI application, it's not really different from a classical machine learning application. In this case, I have to say I have, I think, another slides in which I summarize most of the steps that you need to perform for a generative AI application. But you can see that most of them are also steps that you will need to perform also when you are developing more like a classical machine learning operations. In my opinion, probably the most interesting aspect is that, of course, when you are thinking about larger language models, you need to think about monitoring them over time and also making sure that what we call the responsible AI principles are very well integrated and they're actually respected in those applications. And that's why at Microsoft, we have a few principles that are really more like as industry standards of what we call the AI principles, because it's important, of course, to create these generative AI solutions in a responsible way, but also starting with the design of these solutions. So I really believe that when a data scientist creates technologies that can have a direct impact on our society, for example, it's important to make sure that you have at least these principles in mind, but then most importantly, if there are tools that you can leverage as a data scientist to make sure that these principles are applied and very well integrated in your own application. So let's quickly look at some of these principles. As you can see here, there is a fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. The most important aspect, in my opinion, is about making sure that we are able to open together this box of different principles and understand, okay, as a data scientist and machine learning scientist, how we can bring these principles back into our applications. And so what we have done is to translate those principles into actual goals, or at least extend those principles, AI responsible principle, into actual goals. And so you can see that these are a few goals that are under each of these six principles. The first one, for example, if we take accountability, what does it mean? It means that, of course, as a data scientist, we need to make sure that we impact the assessment. There is an oversight of significant adverse impact with fit for purpose. We do the data governance and management, and then there is always a human oversight and control of your application and the results of your applications. And then, of course, also, when it gets to fairness, which is another very important principle, we need to make sure that, of course, we always look and we monitor the quality of the service. There is also a good allocation of resources and opportunities. There is also a minimization of what we call the stereotypes or demeaning and raising outputs. So this is also a very important step every time that you, as a data scientist, you are building a generative AI application. And then I would say the other important aspect is like how we can also incorporate these six principles into what they call the responsible AI governance framework. We always talk about data governance and machine learning governance, and right now a big focus in our industry has been around the AI governance framework. And so these six principles and all those goals that I was presenting also earlier are then translated into these governance, AI governance framework that, of course, you can use. And the most important aspect is, of course, actually 4 different aspects that are auditing, compliance, reporting, and monitoring. And then the work that a few data scientists have been doing is like how we can translate this AI governance framework into actual machine learning and AI tools that we can use. And so these are exactly some of the tools. Some of them are actually all also they are both inbuilt tools, so tools that you can use directly into the platform that you can use, or there are also most of them they have their Python framework that you can call as a library in Python, and you can integrate them in your own application. But just to look at some of them: fairness, explainability, counterfactuals, causal analysis, error analysis, and responsible AI scorecards. So these are all tools that while you are developing your generative AI solution, you can include. And so, like, for example, just to give you an example, the explainability tool is a tool that you can leverage in order to understand the model prediction. And this tool is generating for you a dashboard that visualize the feature importance values for your model. And so you're really trying to understand why your model is predicting specific results, both at the global level and also at the what we call the local level, so for specific data points. And so this is a very powerful tool. In terms of other content filtering tools that I want to quickly share today, I want to mention the Azure AI content filtering tool. This is a service that includes the Azure AI content safety. This is a sort of a safety system, as the name says, that works alongside a few core models. And basically it supports different languages such as English, German, Japanese, Spanish, French, Italian, Portuguese, and Chinese. And it does 2 different things. Classifies, the first one is that it classifies harmful content into 4 categories via the Azure OpenAI API responses. And the second thing that is also extremely important is that it returns a severity level score for each category from 0 to 6. The last tool that, of course, I want to present today is the Azure AI content safety. This is about incorporating responsible AI, and specifically in a large language model application. And as you can see with these, you can get, of course, all the different tools that I was also mentioning in one of my previous slides. They can all be applied to your large language models application. And then also what is nice is that you can get a very nice dashboard that over time is going to show you how these applications have been following the responsible AI principles. And so it's also a great tool to monitor the integrity of your application over time. Okay, I'm also looking at the time, and I want also to save some time at the end of my presentation for questions. And so I'm going to stop here. I really hope today I was able to present a little bit more in terms of the shift that you need to think about between machine learning operations and large language model operations. What are some of the tools that you need also to build and to operationalize your generative AI solutions? And then I conclude with a few tools that you can use if you want, of course, to integrate those responsible AI principles into your own applications. I'm going to pause here for questions, but thank you so much for listening today.
Well, thank you. I mean, I think that it's fascinating. Thinking about deployment is so different than sort of, you're absolutely right. You get to a prototype, that's great. But thinking about deployment, it does take a different tweak of the mind, I think. And so, yeah, we have time for a couple of questions. I'm looking at the Q&A here. I'm So sorry, folks, if we're not able to get your question, but we can also follow up on the back end with Francesca. So we'll be able to do that. From Angie Yang, she asked, and maybe you might be able to summarize some of the best practices here. How do you incorporate user feedback to continuously improve on the model? Is it automated? I know you touched upon that, but I'm wondering if you might summarize some of your best practices.
Yes, so yes, I totally agree with you, Jenny. It's more like right now in terms of best practices because there are many different tools that you can leverage to do this. So in terms of best practices, or at least based on what I have been seeing around, is really making sure that you have an application that is capturing real data, so the answers from the consumer in real time, and is able to store that data into a data storage that then your application is reading immediately. Usually this is done by leveraging not just one large language models, but multiple large language models in parallel, so that you always are going to have a large language model that is just looking at the type of user feedback in real time. And of course, you need to have also a process to somehow collect, clean, and understand it, like translate the user feedback into actual data that your application is going to consume. And usually, as I said, we do that by creating multiple language models, and one of these is the one that is just collecting user feedback and translating them into data to feed the model. And then there is a sort of a real-time evaluation that is simply put is a really comparison between the current model that we're using and what the user feedback has been saying. And so this is what we have been done. I would say that right now, at least based on my experience, not done in a way that is part of the same application. There is always a sort of an offline evaluation that we perform, and that offline evaluation usually is still a very quick evaluation because again, it's about a comparison between a current solution and then, of course, the user feedback, what we are getting, the data that we are getting from, in terms just of feedback from the users. And so it's not part of that. We have been leveraging different solutions where even if it's not part of the same application, is still done offline in a matter of a few seconds. And that right now, I think, is the best practice that I have been following.
That's really great. I think that, what you're really describing is sort of redundancy in the system in terms of making sure that you're seeing what it is that you think you're seeing.
This is again, sorry, Jen,
No?
this is a fantastic question, and I'm very, very passionate about this topic. Of course, there are many other also like offline ways to improve and keep the user feedback always in mind. Another, in my opinion, best practice that as a data scientist we need to follow is also always trying to share like a survey and also feedback from the users. But I think that right now a lot of data scientists are trying to leverage the user feedback also as a new data to feed the model. And that, in my opinion, is also the very interesting aspect. But of course, that is, again, is a way to try to include the user feedback into your data pipelines and then to improve your final generative AI application.
Yeah, it is the textbook definition of continuous improvement.
Exactly.
So another question about best practices, which is kind of interesting. Do you have any best practices? Do you recommend any best practices for minimizing prompt leaking when providing LLM applications to customers?
Yes, so that is another wonderful question. So yes, best practices for that is really about making sure that, and this is again based on my personal experience, making sure that you are working in an environment where there is a way to do two different things. One is testing multiple prompt engineers, and so engineering application at the same time, because the parallel aspect of it is going to give you the possibility to evaluate the performance also of the different prompts, and also making sure that you are then understanding what is that is actually performing better. And then the other aspect is also working in an environment where there are all those layers about security, privacy, and so on that are allowing you to keep the data that you're using for your prompt saved. So I think I mentioned this in one of my slides for especially when you are trying to use prompt and use your own data in order to optimize the application, we do have right now option and solution in which you can use your own private network also to do that. And that is right now my recommendation. Again, especially if you're working on something that you know you're going to push to production, what's the best way to test? And of course, you need to use your own data, you need to build your own and leverage your own prompt. And so beside the parallel architecture that I was also mentioning before, that is going to allow you also to test and evaluate different prompts at the same time, or at least to have an optimization there. I think the next step is also work in an environment that is already secure, and that it's done most of the time with different type of networks, including private networks, if that can help.
That's so useful. And you know, some of this I know that some of these questions are very practical, but I think
Yeah.
that you know, so much of it has to be designed into the model as you're designing it. So
Yes.
I'm going to end us on a sort of a future-looking question. And you know, what do you think is the greatest challenge as you know, as these models are getting deployed? You know, what do you think is the challenge moving forward? Is it, you know, I know that the Times recently published, you know, safety versus speed, or, you know, maybe it's something else, but what do you think, you know, people who are thinking about deployment, what should they be thinking about now to go, you know, 2 steps ahead or 10 steps ahead?
Yeah, I would probably reply with a very simple answer. In my opinion, is all about data. And I know that here we have been focusing a lot on more like in the speed and the accuracy and everything else. But I would say all these capabilities are, and like every data science machine learning solution, they all start with the data. And so in my opinion, one of the biggest challenges, but also one of the biggest opportunity that we have in front of us is making sure that we have good data that are safe. So I'm also referring to the previous question. And also that, of course, we maintain and we build tools that are allowing us to use always large amounts of data, because without data, we cannot go anywhere. Like we cannot build a good application and safe application, but also at the same time maintaining all those safe limits, like again, security, privacy, compliance, governance. I can keep listing these. And so that is going to be, in my opinion, the biggest challenge for future technologies and future tools for app developers. Like, how can we get the best of both? Of course, we want to use always more data, and without data, we cannot build applications that are actually intelligent. But at the same time, how we can make sure that we protect everybody's lives, and we do in a way that is, again, responsible. And so I don't have an answer, but I think that is going to represent the future for all of us in the tech industry.
Right. Well, thank you so much. This is our last industry seminar of the fall term. We'll be posting information for the spring term soon, so I hope our audience will look out for announcements in our weekly newsletter and on our website. I also want to mention that our annual conference is happening February 1st and 2nd. You can find more information on our website about the workshops and tutorials that we'll be presenting there. And also look out for announcements in our newsletter. So with that, I'll say one more thanks to Francesca. Thanks to our participants for your great questions, and happy holidays, everyone. Thanks. Take care.
Thank you. Thank you so much.